One of the things that you're going to have to do a fair amount of in the near future is to square radicals. You might get the length of one side of a right triangle as root 3, and when you plug that into the Pythagorean theorem, you're going to need to square it. So let's take a number like the root 3 and square it. It's always a good idea to use parentheses so you see what's actually being squared. And when you square something, that means you multiply it by itself. So what this really means is the root 3 times the root 3. And the root 3 times the root 3 we know is the root 9, and we know the root 9 is 3. So that's the answer. The square root of 3 squared is 3. Let's take a look at this a little bit closer. Let's take a look at a pattern. We've got the square root of 2 times the square root of 2, which, knowing our radical rules, becomes the square root of 4, and we know that the square root of 4 is 2. And we know that the square root of 3 times the square root of 3 would equal the square root of 9, and the square root of 9 is 3. And we know that the square root of 4 times the square root of 4 equals the square root of 16, and we know the square root of 16 is 4. And let's do one more. The square root of 5 times the square root of 5 equals the square root of 25, and the square root of 25 is 5. So you might see a pattern developing. If you just cut out the middleman, what you have is the root 2 times the root 2 is 2, and the root 3 times the root 3 is 3, and the root 4 times the root 4 is 4. So what we have is a rule that says the root x times the root x is equal to x. So if you want to write that rule down, that's basically the rule that we're trying to show here. So if you have a number like the square root of 11 squared, it's just going to be 11. And the reason is because you have the square root of 11 times the square root of 11, and based on this rule, the square root of x times the square root of x is x. So the square root of 11 times the square root of 11 is 11. Okay, there's also going to be times where you need to take a radical like 3 to the root 5 and square it. So let's take a look at what that would look like. You've got 3 root 5 and you want to square it. And that means 3 root 5 getting multiplied by itself, 3 root 5. Now, because in multiplication you're allowed to change the order without changing the problem, let's change the order of this. You're going to go 3 times 3 times root 5 times root 5. And all I did was rearrange the multiplication pieces so they get multiplied in the order that I want to multiply them by. The answer will be the same either way. 3 times 3 is 9, and we know from our last example that the root 5 times the root 5 is 5, and 9 times 5 is 45. So let's take a look at one more example where you have, let's say, 4 root 7 squared. And that means 4 root 7 times 4 root 7, and 4 times 4 is 16, and root 7 times root 7 is 7, and 16 times 7 is 112. One little problem area that you want to look out for is sometimes students try to take the shortcut, the root x times the root x equals x, and they do something like this. The root, let's say 6 times the root 6, and then they'll say the root 6. Well, that's not true, but it happens a lot, so I want to point it out where students will get root 6 out of this. The root 6 times the root 6 is just regular old 6. So just be careful that you don't make that mistake, and you should be good. Now you're able to square radicals.